Hi, I'm Jessa, and I love teaching math. Let's get started.
Okay, so let's continue our good discussion about distribution. So I'm going to discuss just one more way, kind of an alternate explanation way of thinking about how to approach this topic of distribution. So let's continue with, let's say we have an example, x plus 2 times x plus 3. So in a previous video, if you look at the playlist, I looked at distribution from a visual standpoint. I consider it to be the area of a rectangle and talked about how to visualize this distribution kind of using geometry. But so that doesn't work for everyone. So another way that I like to think about it is, so I have young children at home. And so I like to think of it as this first component I think of as my children. I have two. And this second component here, I like to think of as some toys. So every child has to have a chance with every toy. And so that's just one way, you have to be fair as a parent, right? Or at least try to be fair. So if I'm looking at this first component, X, it has to have a chance to, kind of play, to be assigned to each of the two components in the second quantity here. So this first component x has to be multiplied by the x as well as the 3. So this is, that shouldn't be a plus. I apologize. That should be a multiplication. X times 3. So everything's fair. So that first child gets his opportunity. And then I have another child who has to be able to be assigned also to both of these other things. So it has to be fair. So the 2 is multiplied by the x, and then the 2 is also multiplied by the 3. And then I add them all up. And so maybe that's a little bit cheesy or simplistic way of thinking about it, but I like to think of math as, trying to promote fairness. Even though sometimes it does seem like a struggle, we want it to be fair, so everyone gets their opportunity. So x times x is x squared plus x times 3. I'm going to rewrite that as 3x. It is standard to write the coefficient, the number, in front of the variable, the x. And we don't put the multiplication sign in. This is just for cumbersome, just so that it's faster to write. It's notation. It's basically the vocab of math, and I think that it comes from a time where paper was expensive and hard to produce. It had to be made by hand, right? Now we have a whole different society, but at the time, you don't want to waste a whole bunch of symbols and a whole bunch of paper by adding all these dots and other things. And then we have here the next component. So we have 2 times x, so I'll write that as 2x, and then 2 times 3, which is 6. Now don't forget that we can always combine, it's called combine like terms. So we call them like terms. So this means, of course, that the x's are exactly the same. So this x here in front, it's a common question for students to ask, why can't they add this x in, this first one? Well, this one is squared, and so it matters, right? That makes it different. This is an orange, for example, whereas these two components, they just have the x. There's no exponent, so they're apples. However you want to think about that. But whenever we're combining terms, they have to be exactly the same. There can be no difference, right? So the only thing that's allowed to be different, I shouldn't say there can be no difference. The only thing that's allowed to be different is the number, the coefficient, right? So I'm saying I have 3 of them and then I have 2 of them. That's fine. The number is allowed to be different, but the variable itself, it has to be exactly the same. So there's no square term. These just have the x. There's nothing in the exponent. There's nothing up above. So these can be added. So I have 3 of them plus 2 of them. So I end up with 5. So I have x squared plus 5x plus 6. And this is the result when I distribute the x plus 2 to the x plus 3. So these two things are equal. So that's just another way of kind of thinking about distribution and thinking about how you're going to progress. In some ways, this is superior to the area type because you don't want to have to draw a rectangle every time you're working a problem, right? You want to be able to get faster at it and be able to just to do it without drawing a whole bunch of stuff. So this has the advantage of being less writing and maybe a little bit faster. But that's another way of thinking about how to do distribution. So keep watching the playlist. Don't panic if it's still a challenge. It's going to be okay. You can do it. I have taught high school. I have taught community college. I have taught at four-year universities, and I've never met a student who couldn't do math. It just takes some time. You can do it. So if this made sense, that's great. If you need a little bit of practice, go back to that distribution playlist and keep watching those videos for more example problems. All right, thank you so much.
If you have extra questions, you can go ahead and post them in the comments, and I'll try to answer as many of those as I can. Thank you so much for watching. Please subscribe to get more help with math and see more of the math content.